In this video, we'll be looking at Chapter 11, Section E.1 on compound events. Let's consider two independent events, tossing a coin and rolling a die. We can represent these two independent events on a 2D grid, like so. Now notice, if we want to get a probability of both a head and a tail, we can find that from the 2D grid. I meant to say a head and a 5. We see that there are 12 total possible outcomes for flipping a coin and rolling a die, but there's only one possible outcome where we get both a head and a 5. And so the probability is 1 out of 12. Now what we just found is the probability of a compound event. Whereas finding the probability of just flipping a coin is a single event, and the probability of rolling a die is a single event, when we find the probability of specific outcomes together, that's a compound event. Now, let's take a look at this a little bit further. Notice that if we were to find the probability of just flipping a coin and getting a head, that would be a probability of 1/2, because there are only two options and there's only one outcome possible. Likewise, with rolling a die, there's only one way that we can get a 5 out of 6. Right? 5 is only one option out of 6 possible outcomes. Notice if we multiply those two numbers together, 1/2 times 1/6, we get 1/12. Therefore, the probability of both event A and event B occurring is equal to the probability of event A occurring by itself times the probability of event B occurring by itself. And this is only true for independent events. In other words, the first event cannot affect the outcome of the second event. And flipping a coin has no bearing on rolling a die, so these are independent events. And we'll talk about dependent events in a later video. Let's take a look at another example. We have two archers, Sunil and Monica, and they both have probabilities of hitting a target. Now if they fire at the same time, they're independent events, and we can find the probability of them both hitting the target at the same time, and we can also find the probability of them both missing the target at the same time. So let's take a look at the case where they both hit the target. Remember that the probability of A and B occurring at the same time for an independent event equals the probability of A occurring and the probability of B occurring. So in this case, the probability of both of them hitting is equal to the probability of Sunil hitting times the probability of Monica hitting. And in this case, we know those probabilities. They're simply 4/5 and 5/6. So if we multiply those together, we get 4/6 or 2/3. And remember, we can leave probabilities in fraction form if the decimals aren't nice and neat. Now the probability of both of them missing is very similar. And we can find those probabilities from the given probabilities at the start of the problem. We know the probability of Sunil missing must be 1/5, which is the difference between 1 and 4/5, her probability of hitting. And the probability of Monica missing is 1/6, or in other words, out of every 6 shots, she misses 1 and makes 5. And so the probability of them both missing at the same time is simply the product of these two, which is 1/30.